like the attempt on the problem. And it's a long explanation because it all depends on what you regard as like the region that's being rotated. So technically it's yes if you viewed it as one region, but if you thought the boundaries defined a different region, then it was incorrect. So that's the part that I'm going to have you guys do in breakout rooms before you even attempt the integrals, is just sketching the diagram, making sure that everybody has the same picture before you guys start to set up the integrals for these. So let's do one together. And if you guys have already done it, you can just kind of cross-check your work and see if it makes sense to you, makes better sense to you after the formal explanation. So let's go ahead and sketch this, and then I'll have you guys type into the chat what you think the description is the region that it's describing. So let me fix my pen. My daughter uses this and she likes her pen thickness really big. So here we have y equals x squared. Oh, that's going to bug me. My graph is slightly crooked, my x-axis. All right, you guys, so you have 5 points. They are describing the region that is bounded by y equals x squared. And I remember one year I did this and I thought it was describing one thing, and then I finally tried to, in my mind, think of a way to describe the region to you guys so that you have the same region as I do each time that you're doing this. So you'll notice that it's a little bit arbitrary. Well, what is this region that they're describing? And so what we find is that on the AP test, the region is given to you. They graph it for you because they don't want this this confusion between, did they mean this region or that region? So let's look at the way that it's described. So they're saying it's bounded by y equals x squared and x equals -2. So x equals -2 is here, and then x equals 2 is over on this side, and then y equals 0. Okay, so I'm going to shade y equals 0 is the x-axis. So I'm going to shade 2 regions, and you guys tell me what you think the region is that's being described. And the axis of revolution I'll draw in red. They want us to revolve it around y equals 4. So notice now we're moving the axis of revolution away from the x and y axis. So now they want us to revolve it around y equals 4. The question is, do they want, and I'll erase the shading because one of them is incorrect, this region in yellow, or do they want this region in blue rotated? What do you guys think? Yellow or blue is the boundary that is best described by those 4 curves? And just reading your comments, you guys, it's literally yellow, blue, yellow, blue, yellow, blue. Yeah, and so this arbitrary call on what the region is where there's is the reason why the AP test usually just tells you guys rotate this region, and this is the curves. And someone typed in green. And yes, it's like that is the confusion. So I would say it's almost like 50-50 what's coming through the chat. So let me erase this and tell you guys as best as I can why I think it should be the blue region. Okay, so the blue region, because when we're describing the region and we're saying it's bounded by y equals x squared, it has to touch as many of these spots as possible. So it also says y equals 0 is one of the boundaries. Okay, so if it's one of the boundaries, then that means the x-axis has to be part of the boundary. And when you're looking at the other curve, I think the x equals -2, x equals 2, and y equals 0, those are just points that touch those curves, as opposed to the blue region touches each one of those lines a little bit more than the yellow. And again, arbitrary, but something that's important to note is on the AP test, there's very few questions where there's a confusion like this one. So after this, now we talk about, okay, what does this look like? Okay, so if we rotate the blue region about the red line, what we find is that there is a gap. So someone says, if it's blue, then it's a washer, right? And that is correct. And the gap that occurs is all of this right here. So you guys are going to get a funny shape from this. You're going to get a cylinder. If you rotate the this line, which is a horizontal line, about the red, you'll get a cylinder. And then what happens is there's this almost like oval-shaped, three-dimensional oval-shaped portion of that cylinder that is empty or just not solid. And so we just want the solid that is formed by the volume of the solid that's formed by rotating that blue region about y equals 4. So here is the fail-proof way of doing it after you guys have obviously have gotten the region correct, is you're going to put 2 dots on your axis of revolution. Always, that's where you start. Okay, so then from there, you're going to find your large R, and your large R is always from that 1 dot is an extension to the curve that's furthest away. And the curve that's furthest away happens to be the y equals 0 curve. Okay, and then the other curve that's closest now, I put a dot on the axis of revolution. So that's going to be my big R. The little r is going to go from 4 to, what should I draw it to, you guys? The second dot, what should I draw it to? What would be the, define the little r? Okay, good. So you guys are typing in x squared. And sorry, I probably should have picked a better spot to put my second dot. But here we go. That's going to be my little r. Okay, so now the 2 equations I set up, remember, is that you guys want the larger volume minus the smaller volume. So that's going to involve the bigger r squared and the little r squared. So we're going to set up what is big R. And big R is always, and you guys, you're going to always do it in terms of top minus bottom. And if it's going in this direction, remember that we're rotating a bunch of discs. If you guys look at the way my cursor is, my circular discs and washers are going to have a thickness that is dx. And notice that these, if you guys were to just sketch this as the height of each one of your cylinders, you're going to see that is with respect to x, so dx. So keeping that in mind, now I know my functions should all be in terms of x. And then going to my big R, I'm going to say, okay, well, the big R is defined by top minus bottom. Okay, the top function happens to be y equals, it happens to be y equals 4. So it'll be 4 minus 0. So that's how we get that cylinder. And you know what, we're going to compress 2 steps in one now. Just as you guys are getting familiar to this, you'll always need a big R squared. So you're going to do top minus bottom squared. Okay, so that's your big R squared. Then you're going to transition and do little r squared. Little r is in green. So little r squared would be top minus bottom. So the top of this function is 4. So this is the function y equals 4 minus y equals x squared. So notice that as you guys move from left to right, it's always 4 on top, x squared on the bottom. 4 minus x squared, 4 minus x squared, all the way through. So we're going to want our little r to be 4 minus x squared. And remember, we're squaring that radius. So the 4 minus x squared portion is little r, and then squaring it is little r squared. Okay, so we have those 2 set up. And now what we do is we go to set up our interval. So this is the volume with respect to x. Washers are circles, so pi. And then I think I'll just write the general formula for now, a to b, a big R squared minus little r squared with respect to x. And so we plug everything in. What's your a, what's your b on this problem, you guys? Type it into the chat. What's a and b in this problem? Okay, hopefully we're thinking this is with respect to x. So good, we want it to go from -2 to +2. And as I plug it in, I might choose to simplify along the way, like 4 squared is 16. So I'm just going to do 16 minus the quantity of little r squared. So as you guys square out that quantity, if we were to do this by hand, that's going to get you filling out 4 minus x squared times 4 minus x squared, 16. And then -8x squared, and then plus x to the 4th. This is definitely something you guys can do by hand. And we'll go from, we'll distribute, and then part of it you guys can do the calculator. But when I say do it by hand, I expect at least you guys to be able to do the antiderivative portion of it. At this point, I'm going to point some, just show you guys one thing that you could have done as well. I just went on automatic mode and wrote down what you guys said. But if you look at the feature of this graph, we would say that the parabola, we know that part of the properties of a parabola is that it's symmetric across the y-axis. So if that's true, I could technically find the volume of just one side of it and double it as well. So that could have been one of my limits of integration. It's possible to go from 0 to 2 and simply just double the volume. So yes, thank you, Newland. I accidentally started to integrate that. So that should be x minus x to the fourth. So from there, I'm just going to point out that on the next step, I'm going to show you guys what I would write. Had I done this problem for the limits of integration, actually, maybe you guys can put this in a different color or highlight it. You can also go from 0 to 2 and then double it as well. That's an option, okay, because of the symmetry. I'll put symmetry here. And because I'm evaluating by hand, I think I'm going to do it that way instead. So down below here, I'm going to double my volume and go from 0 to 2. My 16s cancel out, and I have 8x squared minus x to the fourth that I'm integrating. And we have 8/3 x cubed minus x to the fifth over 5, and that was the reason why I wrote x to the fifth. Started to integrate in my head a little bit too soon. Okay, can you guys go ahead and plug it into your calculator? At this point, it's fine to do it on your calculator with just the fraction portion of it, and verify your answer, or just type in what you think you get for this one. Oh, and you guys, volume should always be positive. So can you check your work if you guys got a negative volume? Yeah, it's kind of a large fraction. Good, Nancy, that's correct. And then if you guys can type in your answer and then a simple yes, if you understand the symmetry aspect of it and why I switched over to 0 to 2, because I just kind of sprung that on you guys. Just type in yes if you understand that part of it. Don't forget to double as well your volume, you guys. Don't forget to double your volume. And by the way, you can also do that with your area problems as well. So if that was an area problem and you were finding the area between the curves of that blue region, you can also just go from 0 to 2 and then double the area as well. That's also an option. And the whole reason why I didn't say why I did that, but if you guys are plugging in limits of integration that are not 0 into, and you're doing it by hand, it's much easier to do the f of b, the antiderivative evaluated at b and a if a is 0. 0 just most of the time zeroes things out. Okay, so the correct answer I see coming through is 448 pi over 15. And someone had their answer in decimal form. That is correct. 93.829 is also in decimal form. So the question always comes up like, is this something going to be, is something like this going to be on the non-calc portion of the test? Again, we're going to do an AP free response today, so you guys will see how it's set up, but most of the times they would not expect you guys to even do this type of fraction on a non-calc multiple choice question. I would say if it ends up on a non-calc free response portion, like your quiz, where it's non-calc and it's free response, then I would say just plug the 2 in, and you can leave your answer with the 2 plugged in, and then 0 if it affects the answer, but leaving your answer in this format and not having to simplify it all the way down with common denominators, that's fine as well. So I'm going to have you guys move to the next page and look at question 6. And we're going to do question 6 two ways. We're going to first do it about y equals 1, and then I think I'm going to have it on a separate sheet of paper. You guys do it about x equals 1. So let's go ahead and graph y equals ln of x is going to come back with a vengeance next next semester, we're going to look a lot at improper integrals with ln of x in it. So I need you guys to make sure you remember how to graph ln of x. So ln of x is the natural log function. If I were to plug 1 in, the way that I might remember this is that the ln function is the inverse of the exponential function. So when I plug 1 in, so let's say if you forgot what ln of 1 is equal to, you can think of this as e to the what power is equal to 1, and that's e to the 0. So this, the ln function goes through that. And also another nice value to plug in might be e. And you guys can see that your boundaries are going to be y equals 0, x equals 1, which we have that point there, and x equals e. Well, x equals e is when I plug ln of, or e into ln of x, I get ln, what is ln of e equal to? Okay, good. You guys are typing in 1. E has the value of 2.71. So if I go on x to about 2.71 and graph that function, then I'm going to go 2.71 comma 1. And this is what my curve looks like with a vertical asymptote going through the y-axis. Okay, so now I'm going to shade different regions, and you guys tell me what regions this is best described by. So they say y equals ln of x, y equals 0, x equals 1, and x equals e is the other. X equals e is right here. And they want me to revolve it about y equals 1. So question is, are they describing the yellow region or the blue region? What do you guys think? Yellow region or blue region? Okay, almost consistently through this time, there is a more of a majority that describes it as blue, with some people saying yellow. Okay, the reason why I would say it's not yellow is that y equals 1 is described as the axis of revolution and not a boundary. However, if y equals 1, so they described y equals 0 as a boundary as opposed to y equals 1. So I'd say the better choice would be the blue is the region that we're going to revolve about y equals 1. So let me erase those shading and then just keep the blue. And go ahead and draw in for me the axis of revolution, which is about y equals 1. Okay, now from there, can you guys type in, is this a disk or a washer? If I revolve that blue region about, is that a disk or is it a washer? Okay, is there a gap or is there not a gap? Okay, perfect. And we're going to do this. Make sure you guys get these correct. If I were to describe, and I'll do this for the big R, if I were to describe big R squared, can you guys write in or type into the chat, what is big R squared? So remember, 2 dots on your axis of revolution is where you always start. So put 2 dots on your axis of revolution and then type into the chat what you think big R is equal to. Good, Wesley. Okay, good, Brandon. All right, so extending all the way to the furthest region out, which is your x-axis, and then little r would be 2 dots, the second dot on your axis of revolution to the region that's closest. Okay, so big R squared, some of you guys described as just 1. That's correct. 1 minus 0 squared is just 1. And then go ahead and do little r next, squared. What do you guys think little r is? And Brennan, I got your answer from before, so you're good. Perfect. 1 minus ln of x, quantity squared. And we're going to leave that. There's certain problems on here that's going to be calculator questions. This is one of them because you won't be able to find the antiderivative of this. I believe on my answer sheet, I did say like use a calculator for this because you won't be able to find an antiderivative for it. So in this case, all you're doing is setup. By the way, a lot of problems on the AP test as well on the free response, it'll say setup but do not solve. Okay, so if that's the case, I'm going to set it up for you guys right now and show you where you want to stop for that and not go any further. So let's say you guys have this big R squared, little r squared, and the question really wanted you guys to, and when I'm drawing these radius, I noticed that the thickness of the radius is dx, so this is volume with respect to x still. And then I have a pi here. There is no symmetry, so I'm going to go from a to b with no symmetry, no doubling. What is your a and b in this case? What's your a and b in this problem? Okay, so you guys said 1 and e, perfect. 1 being smaller than e. Then we're just going to put little r squared 1 minus the quantity of little r squared, which I have right there, and then dx. Okay, and on your calculator, or so sorry, let me clarify. If on the AP test they say set up but do not solve, this is where you guys stop. You don't want to go any further because they might give you guys a wrong answer or take off points if you do end up solving. Because technically you can't find the antiderivative of this. So if you try and you put down the wrong answer, they might mark it wrong. So if they say set up but do not solve, that's as far as you guys go. If they do, if this is on a calculator section, which I can totally picture this being on a free response calculator section, you would then do math and then fn int or the integral. Can I have you guys solve this on the calculator? Type it into the chat, and eventually, if you don't get the correct answer, let me know and I can, again, don't erase everything, just take a picture of it, send it to me on Remind. You guys can do it live, like if you're struggling on getting the correct answer in class, you guys can take a picture of it and send it on Remind. I have my phone here so I can receive those messages and pictures of your calculator. Good, Lucas, that's right. Good, Decline, that's right. Uh-oh, why don't I give you guys the right answer and maybe you guys can verify what you went wrong with, but the correct answer was 4.027. Maybe we didn't multiply by pi, but some of you guys still would be off by that. So 4.027 includes the pi in it. So double check your entry. Perhaps check to see if you guys minus and then had this expression in your integrand. Yeah, and you know, someone just mentioned I forgot about multiplying by pi. You guys over the years, I can't tell you how many times people say that. It's almost on par with I forgot plus c. Okay, so don't forget the pi's and don't over include pi. And some people will start to include pi on their area problems. I've seen that on the quiz coming up as well. The upper limit of integration is e because we're going from x equals 1 to x equals e. Oh, okay, good. Yeah, and if you guys didn't get the correct answer, you can verify that that makes sense to you. All right, how are we doing, you guys? Are we doing okay on this so far on the washers with an axis of revolution that is not equal to? Okay, good. All right, one last problem as an example. Then I'm gonna like kind of put you guys in the breakout room, just make sure you guys all sketch the right features or the right graphs. Is we're gonna take the exact same image. So you guys don't have to redraw it, but if you'd like to just do the integral setup on a different page, if you don't have room, because I can or I have the ability to write it a little bit smaller there, you're gonna take the exact same graph And what I'm going to do is I'm going to recreate the graph because I want to rotate it about x equals 1 instead. So give me a moment to recreate this so I can sketch the image for you. Sorry, it's a little bit not to scale with what I drew before. This time I'm going to change the question. I'm going to change this question to be the axis of revolution. So this is another example. So you guys can just put example number, I don't know, number 3, because this is our third one. And we're going to revolve about, what did I end up deciding to do? I think I said revolved about x equals 1. Okay, so same exact boundaries, revolve about x equals 1. And x equals 1, just as a reminder, is over on this side. So first problem where we're revolving about a line that's vertical this time. Okay, so everything changes once it's like y-axis or vertical. Now I have to switch my train of thought to drawing my my disk and washers and my radius going left and right as opposed to up and down. Okay, so now still same strategy, right? 2 dots on the axis of revolution. So find your axis of revolution, put 2 dots on there. Maybe I should do it in a different color. 2 dots on here. Okay, 1 dot to the region that's furthest away. So instead of the region being furthest away being the x-axis here, it's now to the line x equals e. So I'm going to draw my line extension over to this side, recognizing that everything is now dy. Okay, and then your second dot, you're going to extend it to the region that's closest to your axis of revolution, which is that curve right there. And what variable should you guys be in terms of? Okay, so let's write volume with respect to y is what I'm trying to get. Okay, and then with this one, I'm going to have you guys try to do as much as possible without a calculator, then verify with a calculator, because I think this one's a good one to just practice the antiderivative of with ease. Okay, so now when I'm doing everything with respect to y, I'm going to consider the fact that the equations were not presented to me in y. So this is important for your quiz as well when you guys are doing area. If the area or the region, the original equations were written so that they're all in terms of x, but then they want you guys to find area in terms of y or volume in terms of y, that means all of these have to be converted so that you're writing x, isolating x, and your equations in terms of y. So this equation right here, how would you guys rewrite this so that it's x equals? How do you undo ln? Okay, exponentiate both sides. Very good. So e to the power of both sides. Very good. So x is equal to e to the y. So when I'm looking at my function, I'm viewing this function as this is x equals e to the y. Okay, this is x equals 1. And notice that it's consistent. X equals e to the y, x equals 1. And so when I write my volume, I'm going to need my big R and little r to be in terms of y. So let's do big R first. What do you guys think in the chat? What do you think big R is equal to? Oh, and you always do the bigger minus the smaller. So when we're vertical, it was top minus bottom. X values rightwards are bigger than X values left of that. Okay, so it's always right minus left. Top minus bottom, right minus left. And no matter where you guys are, you want to make sure and double check when you guys typed your answer in, like for example, someone typed in 1 minus e, is that getting you guys a positive number or a negative number? Because if this represents radius, then we want to make sure, we want to make sure that our radius is positive. So it should be the bigger value. 2.71 minus 1, right, would get you a positive value. So it should be e minus 1. Okay, so e minus 1. Quantity squared. That's your little r, or sorry, that's your big R. Go ahead and try to type in what little r is equal to. Good, those coming through are correct. Right minus left, always right minus left. Perfect, e to the y minus 1 squared. Right function minus left function. So technically not function, curves, right curves minus left curve. Okay, now we go and we write our volume. There's no symmetry, so there's no doubling here. It's pi. Everything is in terms of y, including your limits of integration. So what should your limits of integration be this time for this interval? Okay, so my lowest y value is 0. My highest is 1. Very good. So we've got 0 to 1. And then we have big R squared, e minus 1 squared, minus little r squared, e to the y minus 1 quantity squared. If I told you guys that you could do this by hand, there's certain ones that you can and you cannot do by hand, but this one you can do by hand. What do you guys think? Is it worth it time-wise to FOIL this part out? What is this really representative of? Like e minus 1 squared? All of that is just a what? Yeah, e is just 2.71. And if I'm subtracting 1 and squaring it, it's just, as Brandon said, it's just a constant. So if I'm finding the antiderivative of a constant, like say that was just 2, the antiderivative would just be 2x. So in this case, if that's all a constant, I can just keep that as is. And I'm going to do my work down here. I'm going to keep that as is and not bother foiling that out because e minus 1 squared is just a constant. Can you guys type into the chat whether that makes sense to you or not? Do you guys understand why I just put the y there? And just do the derivative backwards in your head just to verify that that's just the constant, right? Whereas the other one, your little r squared, has a variable in it. So for that one, I'm going to work out right here. So if I were to FOIL everything out, I would get e to the y squared is e to the 2y minus 2e to the y, and then plus 1. There's a negative out front. Don't rush your steps on these problems. There's always like sign mistakes. I don't know why I have a negative volume. It's usually one of these steps where you're distributing a negative. So once you guys get there, now we're integrating each one of these term by term. So I want to do this with you guys. When you're integrating e, it's itself. So it should be minus e to the 2y. But when I'm taking a derivative, I'm timesing by 2. So you have to undo that by timesing by a reciprocal of 1 over 2. 2e to the y is just itself. And then minus 1 is your y. Okay, that's the part that I wanted us to do, because at that point you guys have achieved the antiderivative. And what we're doing is plugging the 1 in after that, which at this point you guys would plug the 1s into all the y's and then verify your answers. Can you guys give me a decimal approximation? And then if you guys can just enter the antiderivative in, or the integral in to double check that your answer is correct. So check one of two ways, plugging the 1 in and the 0 in. And 0, the reason why I also did this problem was anytime you guys have a e as part of your expression after the antiderivative portion of it, the 0 doesn't just zero everything out, right? It zeroes out this expression right here, but it doesn't, e to the 0 is not 0. So we want to keep in mind that that's going to be 1. So this is negative a half. This is going to be 1, so that's 2. So keeping that in mind as you're doing antiderivatives with e's in it is that when you plug in 0, it just doesn't go away. And then type in what your decimal approximation is for all of this. I hope you guys are having fun with these problems. These are, I would say, uh, good, easy applications of the problems. There are difficulties when we do get to some of the more abstract stuff in second semester, but this, and then also if you guys aren't really quite visualizing it correctly and you're having trouble with that, let me know as well. And then, Pablo, I just responded to your, I spotted your mistake on the calculator, so you can look on Remind. Yes, and the whole thing is multiplied by pi. Okay, so I got 2.195 pi is correct. If I enter that into a calculator, oh, also, if you guys can just make sure that as you round your answers, if you guys can make sure that you're rounding to 3 decimal places, to 3 decimal places with a pi in it is 6.894.